Hello everyone, welcome back to our data structure lecture. This is our unit 3 stack and queues, and today's topic is reversing a list, recursion and Tower of Hanoi. Reversing a string in a stack. All of you know about stack follows LIFO, means last in first out approach. If we push string one by one, then last string pop first. So here the following are the steps to reversing a string using stack. So first we create array and stored string in that array. Then create a stack. Then push all characters one by one. Then in next step pop all characters one by one and put into the array. The array name is char. Finally convert to the string in reverse. Example for reverse string. The string hello is pushed onto the stack from the buffer character by character, starting with H. Then the characters are then popped from the stack back into the original string buffer. The last character pushed is the first one out. This reverses the order of the characters. So see here, this is our array and we store here hello string. So we first push H into the stack. So stack starting from 0, 1, 2, 3 and 4 index. So first push H is stored in the 0th index. Then push E, then L and then O. Now we pop this string one by one. So first pop character is O. So first is O, then L, then E and then H. So here when we pop string one by one, so we got reverse string. Recursion. Recursion is simply defined as a function calling itself. Recursive functions are very useful to solve many mathematical problems, such as calculating the factorial of a number, generating Fibonacci series or Tower of Hanoi, etc. A recursive function in terms of the program stack. Let's use factorial as an example. 5 factorial is 5 into 4 into 3 into 2 into 1 is equal to 120, and this can be implemented recursively. Program for factorial. Header file is #include standard input output.h. Next here we define function, that is fact in bracket int. Next is main function, int main. So here we write return 0 for this int. Next define variables, that is x and n. X is defined for result and n is defined for number to find factorial. Next is printf, enter the number to find factorial, scanf %d address of n. Example, here if here we enter value of n is 5. Okay. Now see here in this fact function, first check if n is equal to 0, but here value of n is 5. So this condition is false. So we jump to the else part. So else part is return n into fact n minus 1. So here value of n is 5. So 5 into fact 5 minus 1 is 4. Now this fact function is called itself, means here we check again if n is equal to 0. Now value of n is 4. So this condition is false. So now we jump to this statement, 4 into fact 4 minus 1 is 3. Now again this fact function call itself. This function repeatedly call itself till got 0. See here in this figure, first value of n is 5, then 4, then 3, then 2, then 1 and then 0. Means this function is recursively called itself. Okay. Next, when we got 0, then we recheck if n is equal to 0. So here return 1 because here condition is true. Now return 1. Now 1 into 1 is 1, 1 into 2 is 2, 2 into 3 is 6, 6 into 4 is 24 and 24 into 5 is 120. Okay. Means here this function called itself, this is called recursion. So output is enter the number to find factorial. So here enter the number to find factorial, we enter value of n is 5 and here x is equal to fact n, means here n is equal to 120. So print factorial of %d is %d, means n is 5 and % is 120. So here we got result for factorial 5. Tower of Hanoi. Tower of Hanoi is a mathematical puzzle where we have 3 rods and n number of discs. The objective of the puzzle is to move the entire stack to another rod, obeying the following simple rules. Tower of Hanoi is example of recursion. There are 3 simple rules for Tower of Hanoi. First rule is only one disc can be moved at a time. Each move consists of taking the upper disc from one of the stacks and placing it on top of another stack. That is, a disc can only be moved if it is the uppermost disc on a stack. No disc may be placed on top of a smaller disc. Example for Tower of Hanoi. In this figure given there are 3 rods A, B and C, or you can say pegs or tower. So this tower A contain stack of the discs in decreasing order of sizes. We have to move this disc from tower A to tower C, but longer disc cannot kept on smaller disc. So for help, one more auxiliary tower is given, that is B. So using this tower B, we move this stack of disc from tower A to tower C. So let's start. Step 1. First move this smaller disc, that is topmost disc, from tower A to tower C. Then in step 2, move this middle disc from tower A to tower B. Then move this smaller disc from tower C to tower B. Then in step 3, our tower C is empty. Now we move this larger disc from tower A to tower C. Then in step 5, we move this smaller disc from tower B to tower A. Now in step 6, we move this middle disc from tower B to tower C, and finally in step 7, we move this smaller disc from tower A to tower C. So here we solve our Tower of Hanoi problem. I hope all of you understand these two concepts, reversing list and recursion. Thank you.